My name is Richard Lamb. I work for ICANN. I'm the manager for the DNSSEC program there, and I'd like to give a quick update because I realize I'm between you and the wrap-up here. A quick update on where we are as far as deploying DNSSEC for the root zone. Next slide, please. Okay, this is it's a joint effort by ICANN, the U.S. Department of Commerce, and VeriSign. This has been the group that is involved and continues to be involved in managing the root zone, and this has been an effort that we've been working on for the past, I don't know, probably about a year, and it's been going pretty well. Next slide, please. I apologize for there's a delay between when the slides show up and when I see them here on the video. There it is. Okay, quick recap. I mean, none of this stuff should be new to you, but it's after consulting with various cryptographers and various people in the industry, we have a KSK that's 2048-bit, a ZSK that's 1024. The 1024-bit ZSK does get rolled 4 times a year, so there is, for those people that are into this sort of thing, that worry that that's not long enough, the rollover time actually protects us from any possible concerns. There are two camps here, as there are usually, ones that think that's plenty long and some think it's not too long. Signatures will be, the digital signatures will be using SHA-256, which is something that is new, which again goes to the point that the previous speaker, Ralph, pointed out that software does need to be updated and maintained because there is fundamentally a difference between the last versions of Bind and the versions of Bind, which is the predominant resolver software that's out there, and the recent one that supports SHA-256. So that will be a necessary upgrade. As part of the requirements that were handed down to us from Department of Commerce, the key operations are split. ICANN controls the KSK or manages the KSK, and I'll go into that in a minute. And VeriSign manages the zone signing key, which is the key that's used on a daily basis to at least twice a day to update the root zone file. We're doing an incremental deployment. And it's we call it deliberately unvalidatable root zone, and that's specifically to address some of the issues that Ralph correctly pointed out may be a problem with some of the end kind of edge routers that are out there in some of the consumer devices. Next slide, please. Okay, so to address some of those concerns, one moment, please. To address some of those concerns, we are creating basically what it is a signed root zone file that's out there, and it's being published in most of the root zone servers as we speak. And it has full-size packets. One of the problems with the various consumer or access points edge routers are that they have do not deal well with packets that are over a certain size. And so what we're doing is everything but. So it's got everything is correctly signed, except we have deliberately made the keys in the distribution invalid. In fact, if you look at one of these keys, you'll see in there readable text that says, basically do not use this key. And so far, as I said, we have 12 of the 13 root server operators are serving this. And next slide, please. And no problem thus far. Okay, there's a pretty plot that shows what's going on. The very last one is the JRate root server, which is still serving the unsigned legacy root zone, as it were, and all the others have already begun signing with this deliberately unvalidatable root zone. And so far, we have not seen any problems. I mean, all during this process, which started in January, we have very carefully been looking at and studying the traffic patterns in each one of these root servers, with the exception of B there, which we haven't been able to get information from. But however, we've, anyone that's been cooperative, and the majority have been, we've been watching this very carefully, because this is one of these things where once we actually send out a signed zone, there's going to be people that start to rely on it, and that's the fear. If you start relying on this, and it becomes very hard for us to undo or to turn off. So that's not to say there's no point of return should come July 1 when when we actually have a signed route out there, that we can't undo that. But it would be very, very difficult, and so we're approaching this very cautiously. Next slide, please. Okay, and this is pretty recent data. I don't know if you can see it from where you guys sit, but one of the ways that we're trying to determine whether there is a problem is to see if the traffic gets it gets redirected or is diverted to another root server. So, for example, if for some reason a large number of the resolvers out there were having problems, seeing problems dealing with the DNSX signed zone, as it were, in its full size and capacity, then they would automatically start querying other root servers. And so all along we've been looking to see, okay, we've just turned this root server on DNSSEC. We've started deploying a DNSSEC on that root server. We start to look at the ones nearby, or the other root servers, to see if their traffic has increased or not. And so that is one of our primary indicators that something has gone wrong, and that deploying DNSSEC would be a bad thing, that we should stop. Anyway, now that we've had 12 of them doing this, we're very eager to see what the last remaining legacy root server, JRoot, was serving. And if you look carefully on this, the date of the transition of the last set of root servers to deploying DNSSEC was April 14th, and traffic patterns basically did not change. April 14th is somewhere a little bit, it's like about a third of the way to the right of this graph, and the basic traffic levels have not changed. I have to thank Dwayne Wessels and Matt Larson from VeriSign that have been generating a lot of these graphs and working very hard to drill down on this. There are other presentations that have many, many beautiful slides and diagrams describing this. Anyway, next slide, please. This is also this is a presentation of the TCP traffic, because there's a fallback mode for DNS, where if the UDP transport mechanism for some reason does not work, because maybe it cannot handle large packets, or there's fragmentation, which actually is one of the issues, then they should fall back and start making TCP queries as opposed to UDP queries. And again, it's a little harder to tell here, but there's still not any change here on the traffic on the one remaining non-signed root server that's out there. And so that's this is actually good news. It's been one of these things where all three of the organizations involved with this have been very, very conservative and worried about this. DNSSEC has been around for at least 10 years, but deployment has been very it's been an uphill battle to try to get everyone convinced that this is the right thing to do, because it is one of the major changes to the DNS. But so far, so good. Next slide, please. Okay, I'm going to switch slightly here to a different mode. That was a little bit of the engineering stuff that says, we don't have to worry too much about where this is going to go. One of the other things we need to build in here is trust. I mean, anybody can basically generate a signed root and distribute it. There's nothing nothing special about this, but one of the things we have continued to have to fight with various groups is to make sure that the processes that we use to generate these keys and use the keys is completely transparent and visible. And there's a term of art called a key ceremony. These are used often by certificate providers, SSL certificate providers, to engender trust in their particular root certificate. Well, we have the same problem here. We have a root key. And so we have spent a lot of time developing not only facilities. We have two facilities, one in California and one outside of Washington, D.C., in a place called Culpeper, Virginia, that we've built to have these ceremonies in where we will generate keys and use the keys 4 times a year, it turns out, to sign keys from VeriSign. These are currently being fine-tuned. They're quite impressive in my mind, but it's not all theater. I mean, a lot of this is actually very important to have the multiple tiers of security. There's biometrics. There is which some may argue is theater, but we have anti-passbacks, dual occupancy controls, the whole 9 yards here, and all these documents that describe this stuff. This is all very public, unlike any other key ceremony or facility that generates root keys that keeps this sort of thing private. This is one of the few cases where all this stuff is published. It's completely open, and it'll be videotaped. Videotape will be made online, and we will involve multiple people from the outside community and a third-party auditor. Next slide, please. Okay, one of the key items here, and this is actually the application period ends tomorrow. So this is something I encourage anyone who's interested to apply to if they can, and the website is located there. We haven't seen too many people from the UK so far, so this might be a useful thing. In order to engender trust, some people may say, well, you're ICANN, the government, and VeriSign. Why should we trust you? I mean, geez. So one of the things that we've done is built in this process where we involve 21 people from the Internet community. We actually, if you go to the page, it says what we're looking for, but respected members of the DNS technical community or technical community to be a part of the key generation and use. Again, very public thing, videotape, but this would now bring in up to 21 people into the process that would hold various pieces. They wouldn't hold actual parts of the root key, but they would actually hold anything from some smart cards for backup of other parts of the process, as well as physical keys needed to enable us to proceed. So the actual private key for the root of this DNSSEC deployment will be inside a cryptographic box certified to one of the highest levels possible, and so no one ever can access the actual private half of this public-private key pair. However, in order for us to use it, for ICANN to use it, we need to have, turns out we've made it 3 out of 7 in one code, 3 out of 7 on the other, in order to be able to get the credentials needed to enable this device. So this makes the Internet community a direct participant in this process, and they are there to see, witness as well everything that's being done. So anyway, I encourage you to look at that. We are coming close to the deadline, which is tomorrow. Tomorrow in some time zone somewhere around the world. So maybe there's time. Next slide, please. Okay, so the TLD operators would like to, some of them would like to get their changes in as quickly as possible to us. This slide is up here to try to answer that. There are existing methods for TLD operators to give us that information. We're likely just going to use the existing methods for now. There will be an automated method later, I think in October or November, maybe we're shooting for, but for now we'll use that. And we just haven't gotten all the approvals yet, but we anticipate that in the next few months that we'll be able to start accepting those records, which we can then put in the root zone. So, and then on July 1, when we actually change the unvalidatable root zone and put real keys in there, everything will just be signed. Next slide, please. If anyone is interested in any of the real details of this process, some of this I realize it's more policy things, but it does affect all of us. And so there's something called a DNS Practices Statement. It is up on the page. There'll be a link to where all the stuff is at the end. If you have any specific questions that say, well, have they considered this, and who's supposed to, who's responsible for this part of the operation? This is all in this relatively thick, legalese sort of looking document, but it's as thick as it is. It really is the Bible for all this, and so I encourage you to either look at it or refer people to it if they have questions. Next slide, please. Okay, here so far the documentation that's up there. It's at a website, www.root-dnssec.org. We have a requirements document up there, including some of the physical requirements, which are interesting, including the wall construction and things like that. There's a high-level architecture document that just describes the overall view of this thing, and these practices statements. There's a question of how do we publish this trust anchor, which all the ISPs out there running resolvers, for example, would have to put into their resolvers. How do you publish that? How do you make sure people trust it? I mean, there's a number of things in it, and it's non-trivial. We could just simply put the trust anchor on a web page. That's fine, but then there's the question of attestation. How do you know that's really the trust anchor? Since anybody could generate a signed root, that could be a different one. So there, we have a mechanism where we publish a CSR, if you know about SSL, certificate signing request, and we'll sign that, create it into a cert, but so can anyone else create it into a cert and have their own attest to it themselves. Some of the people that would do that could be, for example, people that are part of the key ceremonies that were there, actually saw the operation, saw that we had no cards up our sleeves, and actually witnessed the process. And so they might be excellent candidates to actually generate these certificates. We have a deployment plan, a ceremonies guide, which goes into each one of the steps in the ceremony. The whole point of the ceremonies is that they're scripted for transparency, and that's in there. There's the proposal for these trusted community representatives, and some of the resolving testing with the deliberately unvalidatable root zone. Next page, please.
So it's a question slide.
So we're basically at the end. You can switch to the final page and give all the colleagues that are working on this some of the credit. But this is simply not just DNSSEC at the root zone is not just simply a step in securing the DNS. It is actually one of the largest changes that are out there, and it's going to create an opportunity for another basically chain of trust that people can use to develop various products and various new applications that can secure the internet. So this is more than what it seems on the surface, and therefore I do hope that particularly people of this community that understand the technology do get involved, understand what this means, and do try to deploy it. With that, I really appreciate you guys. I know this is remote and therefore probably not as interesting, but I really appreciate your attention. And please, any questions? I'll listen on the webcast.
Are there any questions for Richard before we move on? I think that was a really good primer, so I really enjoyed that myself. Thank you very much for taking the trouble to present to us. Could you speak to Richard and thank him, and could you turn the bridge down